So welcome to class coaching. We are now discuss about the GATE previous year question papers of heat and mass transfer. Before that, I introduce myself as I am Manoj GA. I did my degree in Anna University with a second rank of manufacturing. So we have to start the heat and mass transfer of previous year questions. So we enter the chapters of heat and mass transfers. So what are the chapters? You already know that. So already we discuss about the previous chapters, that is we know conduction is one of the chapter, then convection the second chapter, then heat transfer, then radiation, then heat exchanger and unsteady heat transfer. So these are the main chapters we are expecting the questions from GATE examinations. Okay, so we'll directly start the heat transfer conduction. Okay, so the conduction, the first question is thermal conductivity is lower for. So all the questions we expect related to thermal conductivity. So we should know what is thermal conductivity of various metals. Okay, so these questions you have to see various 10 to 12 years of GATE examination or 25 years of GATE examination questions. We already have a thermal conductivity. One question is definitely. Okay, so that you will be you have to expect one question from thermal conductivity of this question. So if I enter into the subject, I will give you some small tip. So what is that means? If you have it is given. So we already know that the thermal conductivity of various metals. So we have categorized into three. So we have a solid, liquid and gases. Okay, so in this you have to be understand this chapter, that is typical range of thermal conductivity of various metals at room temperature. Okay, you should know this thing. That means you have to solve any type of thermal conductivity, if it is a high or low or etc. Okay, so that here it is a solid. Solid having highest thermal, in this gap it is a y-axis the thermal conductivity, it is increasing order, and we have to we just analyze this chart. If it is the highest diamond, we know that the diamond. So diamond is the highest hardest metal ever. We already know that. So okay, so diamond have a highest thermal conductivity, followed by pure metals and metal alloys, non-metals, liquids, insulators and gases. So in this type, solid is in decreasing order. So solid is converted into liquid and liquid is converted into gas. So gases have a lower thermal conductivity. So this is a logic behind thermal conductivity. So if you ask any questions related to the question, that is in this question we already discussed wood. So in this that type of wood is a solid, we know. Water is an air, steam at 1 bar. So in this wood is thermal conductivity lower, means we will go for a air. So directly we go to air. So solid is the highest, water is again liquid, air is and steam. So steam has some moisture content. So it is comes to the somewhat of solid. So air is the answer. So again we go for that. So you have to be by heart this thing. Then you have to solve the thermal conductivity of any problem. And other thing, you have to be remember these values. These are the values. Some of the questions they ask helium and the air. So two gases are given as lower thermal conductivity. So that you have to know this numerical value, then you have to solve the problem. Or liquid. So some of the questions we have discussed again. Some of the questions diamond, gold, iron, and some of the questions they are asbestos, cork. So you have to know the particular value. So you have to solve it easily. You get the mark from this. The definite mark. So the answer is nothing but air. So this is the chart of thermal conductivity of 4 things. So the answer is directly air at 20 degree. So why it is 20 degree means wood is a solid metal. So you have to neglect is the highest. Then water. Then steam. So water is a liquid, so you have to neglect it. So somewhat greater than that. And steam. Steam is nothing but somewhat moisture content is there. So some of the solid particles are also there. So it again neglected, and the minimum value at air has a lowest thermal conductivity. Okay. So comes to the next question. So this is a match the property in the various units. This is another thing. All the competitive examinations they ask units. So you should know the units. So we know that the bulk modulus. So what is the bulk modulus? And thermal conductivity, heat transfer coefficient and heat flow. So you should know the definition of each. Then only you have to be understand. So we know the bulk modulus. What is the value of bulk modulus? As per the definition, we know the bulk modulus is equal to So bulk modulus we know the reciprocating of compressibility. So bulk modulus is nothing but bulk modulus is equal to, we know the formula, bulk modulus is equal to 1 by compressibility. So we know two things at one time, compressibility. So what is compressibility? So what is the definition of 1 by compressibility? What is bulk modulus? So bulk modulus is nothing but bulk modulus is equal to change in pressure, that is delta P divided by volumetric strain. So we know the change in pressure divided by volumetric strain. So what is the unit of pressure? So pressure, we know the formula, Newton per, pressure means force acting per unit area, Newton per meter square, divided by change in volume. So volume, we know the volume is equal to meter cube by meter cube, it is cancelled each other. So the answer is Newton per meter square. So that is the answer, that bulk modulus is equal to Newton per meter square. Then second question. Second, the thermal conductivity. So we know the thermal conductivity. What is thermal conductivity? So using the formula for a law of heat conduction, so Q is equal to K into dt by dx. We know the formula, K into dt by dx, where K is a thermal conductivity that you have to be find out. Okay, so we know the area in meter square, Q in watts, then dt is in Kelvin, then dx is in meter. So from that you have to find out the thermal conductivity unit. So here, so you have to K here, put it here, there is watt divided by watt, here m is got watt meter per. So here meter square and meter cancel each other. So we will get watt per meter Kelvin. So the answer is comes to this one. So this is the basic things derived from this. And the next is heat transfer coefficient. So we know the heat transfer coefficient as per Newton's law of cooling, Q is equal to convection HA delta T. Okay, so here we have to find out the value of H, heat transfer coefficient. So Q, you know the formula watts, A in meter square, and in Kelvin, temperature in Kelvin. So that you have to find out the value. So you have to find out the unit of H is watts per meter square Kelvin. So that is the answer. So the answer is 6. And the next one, heat flow rate. So heat flow rate. So heat flow rate means heat flowing per second. So what is the unit of heat? W per second. W per rate flowing per second. W per watts per second. The answer is 1. So this is the answer of the second question. And comes to the third one. So comes to the third question. For a current carrying wire 20 mm diameter exposed to air at H is equal to, so here Q diameter D is given and exposed to air, so it is exposed to air at heat transfer coefficient H is equal to 20 watts per meter square Kelvin. Maximum heat dissipation occurs when maximum temperature. So maximum, so this is the important thing, maximum dissipation, the heat dissipation occurs when the thickness of insulation. So maximum thickness of insulation occurs. So the formula you have to remember, T is equal to max. So the word you have to be remember this, maximum heat dissipation occurs. That means, and you have to find out the thickness means, it is very very important. So you have to be know that this one is RC minus R. So what is RC? This is a critical radius of insulation. So you know the critical radius of insulation in the explanation class. So you have to be remember this formula RC for in this also you have to remember two things. If you are a cylindrical shape means RC is equal to the formula K by H, thermal conductivity by heat transfer coefficients. And for this is for cylinder, and if it is for a RC critical radius of insulation for sphere means 2K by H. So that you have to know the formula. Here the current carrying wire already know the cylindrical shape. So this is a formula. So it comes to the question. So the formula we know the thickness of insulation is equal to RC minus R. So the RC is here the critical radius of insulation of cylinder, that is K by H minus R. So here R, the radius is given 20 mm diameter, so radius is equal to 10 mm. R equal to 10 mm. Then you have to substitute the K value here. K value is given as watts per meter square thickness of insulation, and H is given 20 watts per meter square Kelvin. So you have to substitute the value, you will get the direct answer. So that is the answer for this one. So this is a solution of that thing. So these are, you have to find out the formula, and you will get the answer. RC is equal to K by H for cylinder and wire. So remember that thing. Sphere also 2K by H, that also you have to be noted. So you will get the 0.5 by 20 and thickness of insulation RC minus R. So you will get the answer of this questions. Okay, comes to the fourth question. So the fourth question is two insulating materials. So frequently some of the competitive examinations, they will ask definitely this type of questions, so you should be carefully noted the question. So two insulating materials of thermal conductivities K and 2K. Two materials, you take the two materials K and their thermal conductivities are K and 2K, are available for lagging a pipe carrying a hot fluid. So it will that one fluid is passing through a hot fluid. Inside that, if the radius of thickness of insulation of the material, so that four answers are given. So you have to check all the things. So one should be remember that if the any hot fluid is passing through a pipe or something, you should remember one thing, all the time the highest thermal conductivity in the outer surface and the lowest thermal conductivity should be inside, should be safe. That is the general rule. So that we discussed that thing. So material with the higher thermal conductivity should be used for inner layer, and done with the lower thermal conductivity outer layer. So this is wrong. So comes to the next one. Material with the lower thermal conductivity should be used for inner layer, and one with the higher thermal conductivity for outer. So this one is correct. This one is, it is immaterial in which a sequence of immaterial in which the insulating material are used. So it is not related to that one, and it is not possible to judge unless numerical values of dimension. So no, it is not, definitely no. We will be judge using if the thermal conductivity or if a two insulating material which will be arranged in such a manner that higher thermal conductivity should be outside and the lower thermal should be inside. So that is the thing. And so how it possible means, if you have asked for technically, the lower thermal conductivity is used for inner layer. So if you are using the thermal conductivity, we know Q is equal to delta T by R. So we have to take the spherical equation. So 2 pi L K log R2 by R1 plus this one. So that is you get the resistance. So the 1 by 4K. So we will get the answer of like this. So similarly, in the case of two higher thermal conductivity used for inner layer means you will get the answer like this, R2 by R1 like this. So that finally we have to be analyze the two things. So this is the important thing. So RT1 greater than R2, so that it will be greater than log R2 R3 divided by. So from this equation we have to be equate to RT1 and RT2. So we will get this equation. So what is the conclusion here behind that is low heat transfer when the material with the lower thermal conductivity should use the inner, and one higher thermal conductivity should be outside, as technically we proved it. Okay, so remember one thing, and also you have to remember this thing also, higher thermal resistance. If your thermal resistance is very high, okay, so what is the formula? Q is equal to delta T by R. So if a thermal conductivity is used inner layer, minimum heat transfer. Why? It is indirectly proportional. That is, higher thermal resistance means minimum heat transfer. That means Q directly proportional to 1 by R. So that way also you have to be remember. Also comes to the next question. So the next question is, for a given heat flow and the same thickness, the temperature drop across the material will be. So you remember these three. For a given heat flow for the same thickness, the temperature drop across the material will be maximum. Temperature drop across the material will be maximum. So Q is equal to Ka into dt by dx. So that is the formula to this. So here, so that is a formula, definitely q is equal to minus k into dt by dx, a constant. So in this question, so we have to take this out. So what is the relation? The question is asked in the question is heat flow. For a given heat flow, temperature drop across the material will be maximum. Temperature and heat flow. The question is the relation between temperature and heat flow, temperature drop across a heat flow. So that you will get the Fourier law of heat conduction, q is equal to minus k into dt by dx. So at constant q, a and dx, so we have to be inversely proportional. So temperature drop is inversely proportional to thermal conductivity. So temperature drop is inversely proportional to thermal conductivity as per Fourier law of heat conduction. So that we take the I already given some materials typical values. You should be remember that thing. So the second question is this. So I had to find out the thermal conductivity values. So we know the temperature drop is maximum only when the thermal conductivity is very very low. So in this case very very low is, which one is, glass wool is very very low. So that your answer is C. So your answer is C. So highest thermal conductivity you have to neglect it, and lowest thermal conductivity is your temperature drop across the thing. So the next question, so you should remember from this question, if the thermal conductivity is larger, then temperature drop will be lower as per Fourier law of heat conduction. So comes to the next question. So this is the chart you should be remember, and comes to the next question. So the temperature variation under steady heat conduction across a composite slab. So here the two slabs are here with the thermal conductivity K1 and K2, and it is given composite slab with two materials with the thermal conductivity K1 and K2 is shown in the figure. Which one of the following statements hold? So we have to check each and every one. So this one is K1 greater than K2, this is K1 equal to K2, this is K1 less than K2, K1 equal to K2. So it is also related to what is that thermal conductivity, temperature variation. Again the same question they are asking. So we know the temperature drop. So here the temperature, we take the slope, and here we take slope. Which one is the largest slope? Here there is the smallest slope. So that is as explained here, that since the drop of temperature in the second slab is more, therefore the conductivity on the slab is more than the second slab. So the answer directly comes to K1 greater than K2. So slope is more means K2 value is mean less. So the answer should be second answer. So comes to the seventh question. It is proposed to coat 1 millimeter diameter wire with a thermal conductivity K is given to increase the heat transfer with air. If the side heat transfer coefficient H is given, this K is given, and diameter, and you will get the radius. The optimum thickness of enamel paint. So already we discussed the thickness can be found out by the formula RC T is equal to thickness of the formula by RC minus R. Here RC is equal to, what is the formula for cylinder? K by H, and RC is what is the critical radius of insulation, and for sphere it is 2K by H. That you should be remember. So we go for this. So this we have to be using RC minus the formula, and it is a critical wire means you consider as a cylinder. So diameter is given, so it will be converted into radius. K is given, H is given. So you have to find out the critical thickness of insulation. RC is equal to K by H naught. So optical thickness of enamel is the formula. This one. This is very very important question. So you should remember that thing. So comes to the simple question and the question over. Next question. So the same question again asking related to thermal conductivity in the 2001. So that you descending order of magnitude of thermal conductivity of pure iron, liquid water, saturated water, pure aluminium. So it had to be, so remember already I discussed one chart related to that. So solid having highest thermal conductivity, then comes to the liquid having low, and lowest is gas. So based on that we had to be divided. That means I already discussed with this one. So this one is highest thermal conductivity, we know that the diamond. So followed by pure metals, metal alloys, non-metals and liquids, followed by insulators and followed by gases. So you have to be remember this chart, then you have to be find out this answer, that is this one. So you have to be find out the answer of this thing. So yeah, and also you have to be remember this chart also. This one is the aluminum is a solid, iron followed by iron, followed by water, that is liquid, and followed by gases. Okay, so aluminum having the highest, from this chart we know aluminum is the highest thermal conductivity 237, followed by iron, followed by what is given in the question, water and water vapor. So water and water vapor. So this is the water vapor means steam. So you will get the answer. This is the answer. So we take the A, B, C, D. So what is aluminum here? It is D. So aluminum, this is D, greater than. Then what is iron? Iron here it is A, greater than water. So liquid water is B and greater than, what is that, C. So this is the answer. So the choice and the answer is D, A, B, C. So this is the answer. Okay, so just you have to be remember what is that. You have to be remember that full chart of thermal conductivity related solid, liquid and gases. So comes to the next question. So this is a common data questions. They are definitely asking the 2-mark questions in the GATE examinations. So here we find out heat is being transferred by convection. Okay, so we know the convection formula, Q is equal to HA delta T as per Fourier law of heat conduction. So and from a water of 48 degree, so temperature is given for a glass plate whose temperature, surface temperature also given. So 2 temperatures given. So why it is given means 2 delta T. Q, we know the formula of heat convection. Heat of convection is equal to HA delta T. So delta T, the 2 temperatures are given. Thermal conductivity of water. Again, the thermal conductivity of water is given, thermal conductivity of glass is given. So thermal conductivity of water and glass, K of water and K of water and K of gas also given. The spatial gradient of temperature in the water glass interface, that you have to be find out. Spatial gradient of water gas interface. So you should remember interface. This type of water glass interface type of problem they were asked, means they are to you have to be, go through the question. 2 thermal conductivities are given. Which one is thermal conductivity of water is given, thermal conductivity of glass is given, and you have to be find out the temperature of the water interface also given. Water interface is given as dt by dy is equal to. So similar, so you have to be in this type of question, they have to be equate thermal conductivity on both sides. So what is the value of temperature gradient of glass is given. So temperature gradient of water is already given. So I have to find out the temperature gradient of water in the interface. So solution is nothing but you have to find out it is given TW and TG as a convection. Then KW, thermal conductivity of water and thermal conductivity of gas is given. So this is it is also given dt by dy, that is temperature gradient of water, that is 1 into 10 power 4. These are the data given. So what you have to be find out, the value of temperature gradient of the glass you have to be find out. Water is given. So that this is the thing you have to be remember this type of questions. So what is that? At water glass interface, we know the formula. What is the conduction? Q is equal to minus K into dt by dx. That is the formula of Fourier law of heat conduction. So here you equate both. If it is both of them are in the inside, it is here we equate both of them. That is minus KW, that is thermal conductivity of water into area into dt by dy of water, that is equal to minus Kg into glass, thermal conductivity of glass into area into dt by dy of glass. So simple. So areas cancel each other. It is a constant area. If it is not given, you have to be cancel each other. So here, what are the equations given in the question? Kw is given, then water interface is given, then dt by dy is you have to be find out, and Kg is given. So simple. So you have to substitute these values. So you will get the answer. So the answer in this question is 0.5 into 10 power 4. So this is the answer. Answer is C. Okay. So comes to the next question. So again this is a linked type question. So one more. Okay, only one question they ask is the answer is C. So comes to the next question. So next question, so related to this one, this is a linked question. So we will expect two questions are there. So the second is heat transfer coefficient in watts per meter. Simple, HA delta T. So Q, we know the formula. Q convection of water is equal to Q conduction of water. You have to substitute, if it is in a water glass interface, so you have to substitute Q convection of water is equal to Q conduction of water. So we know the conduction of water, what? K into A into dt by dy at. Then Q convection is equal to what is that? HA delta T. So here we here HA. So A is cancel each other. So here A is cancel, H is there. So A is cancel each other. So that the remaining thing is HW into what is the temperature difference that is given in the question, and KW and 1 into 10 power 4. So finally we get the HW answer. So this is the second question. So the second question, heat transfer coefficient watts per meter square Kelvin. So it is 750 watts per meter square. That is the answer. This one is your answer. Okay, so comes to the next question. One dimensional. So the question is question number 11. One dimensional unsteady state heat transfer equation for a sphere. For a sphere, remember sphere and cylinders are there. So sphere with the heat generation. So noted that one dimensional unsteady state. So steady states are there, unsteady states are there. So cylinder is there, sphere is there. So just you have to remember one dimensional unsteady state of heat transfer equation for a sphere with a heat generation at the equation rate of Q can be written in the form of. So we know that this equation it is related to cylinder, which is what that it is a unsteady of cylinder, and this is unsteady of sphere, and this is unsteady of again steady of cylinder. This is unsteady of steady of sphere. So the answer is this one. So answer is 1 by r square into dou r by dou t into r square and dou t by dou t dou r plus q by k into 1 by alpha into dou t by dou t. That is the answer.